if any two opposing forces are attaining simultaneously, such state we call it as equilibrium. Generally, we can classify the equilibria into two main classification. One is physical equilibrium and the one is chemical equilibrium. The rate of melting of solid is equal to the rate of freezing of liquid is called as solid-liquid equilibrium. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, today we are going to start with the new unit called Equilibrium. This is a unit 7 in your first PUC Chemistry. So before going to discuss with this unit, let's see the weightage of this unit. From this unit, we can expect 11 marks. There is a 1 mark question and there is a 2 5 mark question. So, and the question numbers are question number 3 from the part A, the question number 33 and 34 from the part D, that is in the 4th main. We can expect this question from this unit and the total weightage will be 11. So, let's see what we are going to discuss in this session. In this session, we are going to understand what is actually a equilibrium and we are going to understand the classification of equilibrium, physical equilibria and equilibria in physical processes and equilibria involving a dissolution of solid or gases in the liquid and general characteristics of physical processes also we are going to understand in this session. So, first we will understand what is a equilibrium. We all know that in our universe, there are many different natural and artificial processes are taking place. Correct? No? If any two opposing forces are attaining simultaneously, such state we call it as equilibrium. You can take the example of the spherical shapes of stars as well as with the planets. So here, the spherical shape of the planet as well as with the stars is mainly attained due to the two reasons. One is because of the thermal expansion and another one is due to the gravitational contraction. So due to this, we can see the spherical shapes in the planets as well as with the stars. So now you have got the idea about the equilibrium. It is a tendency of two opposing forces to attain simultaneously. If any two opposing process, if it is attaining simultaneously, we call such state as equilibrium. When we are understanding this equilibrium constant, we need to understand the two types of the chemical reactions which is happening at that time. One is a reversible reaction and the one is irreversible reaction. If I say it is a reversible reactions, where my reactant is giving rise to the product. Meanwhile, the product also can give rise to the reactant, which indicates that the reactions can go in the forward reaction. Meanwhile, it also comes back to its original state. That means that it can also come back to the backward reaction. Okay, such reactions are said to be reversible reaction. Coming into the irreversible reactions, only the reactant is giving rise to the product, but the product is not giving rise to the reactant. Such reactions are said to be irreversible reaction, where you can see that A plus B is giving rise to C plus D. Okay, but C plus D is not giving rise to the A plus D. It is going only in the forward direction, not backward. Such reactions are said to be irreversible reactions. So, hope you all understood with the definitions of equilibrium and the types of chemical reactions which is taking place with the equilibrium. Next, we have classification of equilibria. Generally, we can classify the equilibria into two main classification. One is physical equilibrium and the one is chemical equilibrium. Physical equilibrium will involve the physical changes, whereas the chemical equilibrium which involves the chemical changes. Again, we can classify this chemical equilibria into molecular equilibria and we have one more type, that is ionic equilibria. The molecular equilibrium which involves only the molecule, whereas the ionic equilibrium which involves only the ions. Okay. So more about only the physical equilibrium as well as with the chemical equilibrium we are going to understand by this unit. So in this unit it is mainly focused upon the physical equilibrium as well as with the ionic equilibrium which comes under the chemical equilibrium. So how do we classify the equilibrium? Equilibrium can be broadly classified into two types. One is physical equilibria and the one is chemical equilibria. Physical equilibrium which involves a physical change, whereas the chemical equilibrium which involves a chemical change, again it can be classified into molecular as well as with a ionic equilibrium. Okay, and the molecular equilibrium which involves only the molecule, whereas the ionic equilibrium which involves only the ions. More about the physical and ionic equilibrium we are going to understand in this unit. Okay, first we will understand what is a physical equilibrium. The equilibrium in which two opposing processes that takes place simultaneously and equally, and this involves a physical change when two opposing forces, okay, when two opposing forces which is happened simultaneously, and that too that involves what? Physical change. Such process or such equilibrium state we call it as physical equilibria. Example is the water and the water vapors in the equilibrium in the closed container. For example, if you take the closed container and you have taken the water, okay, you have the water molecule here. We know that water molecule can easily get evaporated, correct now, and goes to the vapor phase. So you can see that the water in the liquid state can easily get evaporated into a vapor phase. Again that condense back and come to the liquid state only. It is the best example for the physical equilibrium where only the physical change which is happening, even though the two opposing forces which is taking place or it is happening simultaneously. Hence we call this process as physical equilibrium. Okay, you can see that the water in the liquid state is going to change its physical state to the gaseous state. Again the gaseous state is condensed back and coming back to the liquid state. Hence it is a reversible and it is a physical equilibrium where it involves the equilibrium state at a physical changes. Next, equilibrium in a physical processes. Equilibrium in a physical processes, again it is classified into three types. The first one we will see with the solid-liquid equilibrium. The equilibrium in which the rate of melting of solid is equal to the rate of freezing of liquid. What does it mean? The rate of melting of solid is equal to the rate of freezing of liquid is called as solid-liquid equilibrium. The equilibrium that exists between the ice and water is an example for solid-liquid equilibrium. And in the closed system, if you take the ice at 0 degrees Celsius and the water which attain the equilibrium, at that point the rate of melting of ice is equal to the rate of freezing of water, and this is known as equilibrium, that we call it as solid-liquid equilibrium, and this equilibrium can be represented as water which is from the solid state, that is nothing but ice, and which is attaining a equilibrium with the water molecule, and this is a liquid. Okay, so this is the best example for solid-liquid equilibrium where you can see with this figure. I am taking an ice cube at 0 degree in a closed container where it is mixed with water. The rate of melting of ice is equal to the rate of freezing of water, rate of freezing of liquids. Okay, so this attainment of the two opposing forces simultaneously which results in a solid liquid equilibrium, which attains what? Solid liquid equilibrium. Okay, so this is a first type of the physical processes, only the physical changes which is happening. We have one more type, that is a liquid vapor equilibrium. We will see what is the liquid vapor equilibrium. The equilibrium in which the rate of evaporation is equal to the rate of condensation of the vapor, and it is known as what? Liquid vapor equilibrium. Evaporation of the water in the closed vessel is an example for liquid vapor equilibrium. In this processes, the rate of evaporation will be equal to the rate of condensation and equilibrium will be represented with an equation. You can clearly understand with this diagram. Okay, this is a closed vessel. In this, I have taken the fixed volume of the water. We know that the water molecules can easily get evaporated, correct no? So when the water molecules, when it start evaporating, it goes to the vapor phase, correct no? After some time, this vapors will be condensed back and coming back to the liquid state. Okay. Here you can see that the rate of evaporations of the water molecule which is equal to the rate of condensation of the water vapors. Correct no? So this is known as what? Liquid vapor equilibrium. Such equilibrium which is known as what? Liquid vapor equilibrium. You can say with an equation, you can see that the water molecule in the liquid state will be start evaporating to the gaseous state. When the vapors of the waters, when it is condensed back, again it is come back to the liquid state only. So during this process, you can see that two opposing forces are attaining simultaneously. Hence, it attains an equilibrium, and such equilibriums are known as what? Liquid vapor equilibrium. Why it is known as liquid vapor equilibrium? Because it is a physical change where from the liquid state to vapor phase, the molecules are moving. Okay, from the liquid state to vapor phase, again from the vapor to liquid state. Hence, it is named as liquid vapor equilibrium. We have one more type, that is the last one, that is solid vapor equilibrium. The equilibrium in which the rate of evaporation of the solid is equal to that of condensation of the vapor into the solid. This is known as what? Solid vapor equilibrium. The sublimation of iodine to the iodine vapor and condensation of iodine vapor to the iodine is the best example of solid vapor equilibrium. In this equilibrium, the rate of sublimation of the iodine are equal to the rate of condensation of the iodine vapors. You can see with this diagram. I am taking a test tube here. To this test tube, I have added the iodine, which is a solid. We know that the iodine solid, which is a dark violet in color. Okay. When the crystals of the iodine, when it start evaporating, it goes to the vapor phase. After some time, it is condensed back to the solid state only. So, what does it happen here? The rate of evaporations of the iodine to the vapor phase are equal to the rate of condensation of the iodine vapors to the solid state. Such equilibriums are said to be solid vapor equilibrium. Okay, you can see with the reaction where the iodine from the solid state can convert it into vapor state. Again from the vapor state, it will be condensed back to the solid state. Hence, it is a reversible physical change and it is a solid vapor equilibrium. Understood? Next, we have the equilibrium involving dissociation of the solids or gases in the liquids. Okay. Again, there are of two types of the equilibrium can be expected here. One is solid solution equilibrium. When a slight excess of the solid solute is added to the fixed amount of a liquid solvent, some amount of the solid solute remain undissolved in it and appears as if dissolution process has been stopped. But actually, the dissolution and the crystallization which is taking place simultaneously to some extent, and the system will be attain the dynamic equilibrium. It is an example for what? Solid solution equilibrium. Remember, the best example you can take is when you are taking a glass of water, you can add a teaspoon of sugar again and again to the same glass of water, correct? No? After a few hours, you will come to the observation that if you add few more crystals of the sugar, the water will not get dissolved that crystal. By our naked eyes, it shows that the water is not having that much of capacity to dissolve the more crystals of the sugars. But actually what it is happening, the sugars which is undergo dissolution process, meanwhile it also undergo crystallization process. So such equilibrium which is attaining by two opposing forces are attaining simultaneously, hence that equilibrium we call it as solid solution equilibrium. Okay, the best example is addition of sugar to the glass of water. Okay, and such equilibrium are also known as what? Dynamic equilibrium. The equilibrium in which the rate at which the solute particles goes into the solution phase is equal to the rate at which the solute particles are entered to the solution phase to the solid phase is said to be solid solution equilibrium. The best example is sugar. When it is dissolved in an water, it forms a sugar solution phase. If you add few more crystals of the solid, again it will dissolve. During that addition process, you will observe that at the particular point, the crystal will not dissolve. That is mainly because that is the equilibrium state where the dissolution and crystallization which is happening simultaneously. Okay. Next, we have one more type, that is the gas solution equilibrium. The equilibrium in which the rate at which the molecules of the gases go into the solution phase will be equal to the rate at which the molecules of the goes in the solution phase or go back to the gas phase. This is known as what? Gas solution equilibrium. The best example is soda water in the airtight closed bottle is an example for gas solution equilibrium. So hope you know that in the preparations of the soft drinks like Coca-Cola, Mirinda, Pepsi, etc., they'll take the liquid and they'll allow a liquid to dissolve with the gases, with the carbon dioxide, correct? No? When the liquid is dissolved in a gas, the higher pressure will be applied to get that soft drinks, correct? No? So here the gas as well as with the liquid which are attaining a equilibrium to form a gas solution equilibrium, correct? No? This is the best example for gas solution equilibrium. You can see that carbon dioxide is a gas. When it is dissolved in a solution, it forms a soft drinks. That is why when you open the mouth of that soft drinks, a lot of hissing sounds will be come out. That is mainly because of the carbon dioxide. Hence, it is also named as soft drinks are also named as carbonated drinks because they have added the carbon dioxide to dissolve that gas with a liquid. For that, we can understand with the most familiar theory known as Henry law. It states that the mass of the gas dissolved in a given mass of the solvent are proportional to the pressure above the solvent. Pressure of the gas above the solvent. So, hope you all understood with this topic about the equilibrium involving the dissolution of solid or gases in the liquids. Next, we have general characteristics involving in the physical processes. Okay, the equilibrium which is established only in the closed system at constant temperature. This is the first characteristics. Then all measurable properties of the system will be remain constant. Both opposing forces which occurs at the same rate to attain the equilibrium, and when the equilibrium is attained, it is characterized by the constant volume and one of its properties at a given temperature. So these are the main general characteristics of the physical processes. Okay. In the next class, we are going to discuss with the equilibria of chemical reactions. So by this, hope you understood with the introductory part to the equilibrium chapter. I'll come back with the next session. Till then, take care, be safe. Thank you.